Okay, good morning learners. How are you? Hope you are doing well. I am Mr. Joshua Rotich. I will be taking you this unit, chemical analytical method, that is CAM, and we shall start by listing down the learning outcomes. And in this, for today's lessons, I have 3 learning outcomes. The first learning outcome is you start by definition of what volumetric analysis is. The second one will be key concepts used in volumetric analysis, and then the third one will be types of volumetric analysis. We shall go in that order. We shall start by defining what volumetric analysis is. From our definition, volumetric analysis is also known as titration. Is technique used in analytical chemistry to determine the concentration of a substance in a solution by reacting it with a reagent of known concentration. It involves measuring the volume of solution required to react with a given volume of analytes. That is a key definition of volumetric analysis. Secondly, we shall go straight to key concept used. And the first concept used in volumetric analysis is titration. And titration is a process where a titrant in a solution of known concentration is added to an analyte. So that is a solution of a known concentration to react the end equivalent point, which indicate the completion of reaction. That is titration, a process where you react a titrant, that is a solution of known concentration, reacting with an analyte or a solution of a known concentration to reach the equivalent point, which indicate the completion of the reaction. The second one is equivalent point. Equivalent point, this is the point in titration where the amount of titrant added is geometrically equivalent to the amount of substance in the analyte. Okay. Equivalent point, this is the point in titration where the amount of titrant added is geometrically equivalent to the amount of substance in the analyte. At this point, the reaction between the titrant and the analyte is complete. That is definition of equivalent point. Let us move to the third one, end point. The end point in titration is the point where a visible change occurs, often indicated by a color change due to the presence of an indicator. The endpoint is used as a practical approximation of the equivalent point. Yes, it is normally used as a practical approximation of an endpoint. And then the fourth one, we have what we call titrant. The titrant, these are solution of known concentration in titration. Solution of known concentration, that is a titrant. And then the fifth one, we have what we call analyte. The analyte are solutions whose concentration is being determined. That is a solution whose concentration is being determined. That is the analyte. The sixth one, we have an indicator. An indicator is a substance used to signal the endpoint of titration. These are a substance used to signal the endpoint of titration. It is often change color when the reaction is complete. We have some examples like phenolphthalein, methyl orange, and so many others. And then the seventh one, we have what we call concentration. Concentration is defined as the amount of solid dissolved in a given volume of solution, often expressed in molarity. That is a capital M. It is the amount of solid dissolved in a given volume of solution, and it is normally expressed in molarity, and you normally write it with a capital M. And then the next key concept that we are going to do is types of volumetric analysis. We normally have 3 types of volumetric analysis. The first one is acid-base titration. This is normally used to determine the concentration of an acid or base. Like when you are reacting, examples is titration of hydrochloric acid with sodium hydroxide. You can be given a hydrochloric acid of known concentration may be 0.5 molar, and then you titrate with a known concentration of sodium hydroxide. That is a best example of acid-base titration. And then we normally use various indicators depending on the strength of this acid or base. But for this one, phenolphthalein is normally used for strong acid and strong bases. So for this, we normally use phenolphthalein because of it is normally used when you are performing a titration of strong base and strong acid, like this one, HCl and sodium hydroxide. So in this reaction, HCl reacts with sodium hydroxide to produce sodium chloride and water. So the mole ratio in that reaction is 1:1. And then you proceed on doing your own calculation after that. The second types of titration is redox titration. In this titration, the indicators, we don't normally use the indicator. It is used normally this titration is normally done with two works, either on oxidizing or reducing agent. Example is titration of potassium permanganate with oxalic acid. Normally we don't use an indicator in this titration because some of these reactions normally produce their own colors. So the indicator, normally we don't use the indicator in this reaction. And then the third one is what we call complexometric titration. It is used to determine the concentration of metal ions that form a complex with ligands, like editor. Examples of this is determination of calcium or magnesium concentration with editor. So the normal indicator we use here is what we call an iriochrome black T. This is the best indicator we use in this complexometric titration. And then we have another one, what we call precipitation titration. This one is normally used to determine the concentration of ions that form precipitate when they react with reagent. Examples is when you react sodium nitrate with sodium chloride to determine the chloride ions. We normally use potassium chromate as an indicator in this reaction. And then those are the four types of titration we have. And then the next steps is, let us look at steps in volumetric analysis. The first step in volumetric analysis is preparation of solution. You prepare solution of known concentration. That is what we call titran. Prepare the analyte and titran solution. Titran is solution of known concentration, while the analyte is the solution that you are going to determine their concentration. Ensure that the titration concentration is known accurately. E.g., you can use a standardization to know the concentration of that particular item. And then the second one is the selection of indicator. Choose an appropriate indicator based on the types of reaction. For example, on our previous part, on our previous titration, like of HCl and sodium hydroxide, we normally use phenolphthalein indicator, while on the redox we don't use an indicator. The next step is you set up a titration apparatus like burettes, all those apparatus that are used. And then the fourth one, we have titration process, and then lastly is calculation. Up to that point, class, I think we are through with the lesson, unless anyone of you has a question. If there is no question, I'll give you some assignment here that you go and perform it. Can you go and list down important consideration that you are supposed to do during titration? I require that assignment to be submitted on your respective e-portfolios, and then I will go through them. God bless you. That is the end of my lesson. Be blessed.